Hello, today's April 27th, and we're going to finish up Unit 12, Lesson 3. We've already done the first half, and today's the second half. And we're on pages 410 to 413 in your notes, so if you can grab your notes in those pages, and you'll need a pencil. A couple of colored pencils would be nice, not absolutely necessary, and a calculator. And tonight's homework, or today's homework after you finish viewing this video, is on pages 416 and 417. So let's get started on page 4. On page 410. It's the first page of our notes for this lesson. So I'm going to ask you to please shut off the video right now for a couple of minutes, and I would like you to read this story. This is a story about a school district in Wisconsin. So shut this off, take a couple minutes, just read through this top part, and then we'll talk about what it means. So this example is a little bit different than the previous examples we've done in Lesson 3. The story goes that there were doctors in Milwaukee that saw a lot of teenagers that had asthma. They maybe thought that living with a smoker had something to do with it. So they asked their high school to survey their students to see whether or not having asthma and living with a smoker had anything to do with each other. So with the results from this survey from the high school, maybe they could see some correlations. So the high school went out, surveyed their students, reported back 3 probabilities. The probability of having asthma is 0.193. The probability of living with a smoker was 0.2421. And if you go on later into the story, the probability of having asthma and living with a smoker was 0.120. So what we're going to do is try to make conclusions based on just the 3 probabilities that were gathered from this survey. One way is to make a hypothetical 1,000 table. We weren't sure how many total students there were in this high school, but let's assume that there were 1,000 students in the high school, and what we're going to do is from just those 3 probabilities that we gathered from the students, we're going to be able to fill out an entire two-way table with those pieces of information. So the first thing down here, after you read this story, the first thing that this asks is the probability that the student has asthma is 0.193, has asthma. So this probability can be used to calculate one of these cells, cell 1 through 8, and this 1,000 right here means we're assuming that the total population of the high school was 1,000 people. So if we're looking at the people who only have asthma, we are looking at only this row right here. This is the row that talks about the students that have asthma. So if the probability is 0.193, we can just multiply 0.193 times 1,000, and we can fill in cell 3 with that product. 0.193 times 1,000 is 193, so we can fill out cell 3 with that number. So it says which cell is connected to that? That is cell 3. And using this probability, 0.193, multiplied by the whole student population, that will give you 193 that we can put in that cell. The next thing says the probability that they live with a smoker is 0.421. Well, that's a different situation. We've got a smoker here, 0.421. So what we're going to do is we're going to look down, instead of down over the rows, we're going to look down the columns. So this column right here is talking about living with somebody who smokes. So if the probability that somebody in the high school lives with somebody who smokes, we are talking about this cell 8 down here. This 0.421 right here, probability of having somebody in the house that smokes times 1,000 means that we can fill out cell 8 with 421. It says which cell is connected? Well, cell 8, because that's the total number of people in that high school who live with somebody who smokes. So use that probability, which is 0.421, multiplied by the entire student body times 1,000 gives 421, assuming there are 1,000 people in the high school. So this is the later on piece of information. Later on, we've got an additional probability that says that some student has at least one person who smokes and has asthma. So we have both somebody who smokes and has asthma is 0.120. So which one of these cells is related to that? Well, somebody who has asthma is in this row right here. Somebody who smokes is in this column right here. And the overlapping cell between this row and this column would be the person who both has asthma and lives with a smoker. So which cell is that? That is cell 2. And how do we get that? Well, we have a probability of 0.120 multiplied by the 1,000 people in the high school, and that'll give you 120. So just from those 3 pieces of information that was gathered through the survey, we can fill out this entire two-way table, because in the total column, these 2 cells have to add up to 1,000. These 2 cells have to add up to 1,000. This whole row, or this whole column, these 2 cells have to add up to 421. So let's start filling out some of these pieces of information. So you're going to have 193 plus what is 1,000? Well, 193 plus 807 is 1,000. Those add up to 1,000. 421 plus what? Plus 579. So those 2 add up to 1,000. Now we've got this row right, or this column right here, 120 plus what is 421? 301. And now we have this row right here that we can add up. Cell 4 plus 301 equals 807. Do a little bit of arithmetic, maybe in your calculator, you're going to get 506 people. And last but not least, this plus this must add up to 579 at the same time as cell 1 plus 120 adds up to 193. So if you do that arithmetic, you're going to get 73. 73 plus 120 is 193. 73 plus 506 is 579. So now we have the whole entire two-way table completed with just 3 pieces of information. We're assuming that there are 1,000 people in that school. So moving on, we have up at the top, we have the numbers that we just put into the table already typed in. And based on this two-way table, we're going to estimate some probabilities, both as a fraction and as a decimal. We're going to put those numbers into our calculator. So first of all, the first question says, a randomly selected student has asthma. So when you have this first sentence, has asthma, you're just going to say, we are only going to look at the has asthma row. You're not going to look at any other numbers. You're just going to look at the numbers in this row, 73, 120, 193, because these are the people that have asthma. What is the probability that this student has at least one household member who smokes? Well, you're looking at this row, at least one household member who smokes. There are 120 of those people. So 120 divided by the total number of people who have asthma in the school is 193, and that is the fraction probability. Then all you have to do is grab your calculator, and you can divide 120 by 193, and your calculator should tell you 0.622 rounded correctly. So that's approximately equal to 0.622 because a 7 changes the 1 into a 2. The next question says, a randomly selected student does not have asthma. Okay, so that's looking at the different row. So if the student does not have asthma, you are only looking at this row right here. The numbers 506, 301, and 807 does not have asthma. What is the probability that they have at least one person who smokes? Well, here's the column of at least one member who smokes. So only looking at the not having asthma, you're going to say, well, there are 301 people in that school who don't have asthma but live with a smoker out of the total of 807 people who don't have asthma. You're only looking at those numbers. So that is the fraction. If you take your calculator out and divide 307 by, or 301 by 807, you are going to get that's approximately equal to 0.373. rounded to 3 decimal places. And then the next example says, now we have a randomly selected student has at least one household member who smokes. Okay, so now we're only going to talk about the people who live with smokers. Well, which ones talks about the smoking? This column right here, you're only looking at the column of the smokers for this next letter C, the 120, 301, and 421. It says, what's the probability that the student has asthma? Well, student has asthma. There's 120 of those people divided by the 421 people altogether who live with a smoker. So when you divide that in your calculator, 120 divided by 421, you're going to get that as approximately equal to 0.285, rounded to 3 decimal places. So do you think that whether or not a student has asthma is related to whether or not this student has at least one family member who smokes? That's a big question, and that's asked by the medical community a lot. So what we can do is we can take some of these real numbers and we can make some mathematical conclusions about that, but we're not going to do that with this lesson. We're going to come back to this at a later lesson, and we're going to do some comparisons with this these numbers to actually answer this question. So we're going to come back to this, not today, but later on. Down at the bottom, there's another exercise, number 10. I'm going to ask you to shut off the video for a minute or two and just read through exercise 10. You can read that up until we have a two-way table. So shut that off, read it, and then I'll summarize it for you in a minute. So in this example, we have 3 probabilities given to us again, and we're going to create a hypothetical 1,000 two-way table again. We're going to do this once again. So what we know from this information is that 40% of the students play sports after school. So if this is a hypothetical 1,000 two-way table, what we're going to do is we're going to put the total of 1,000 down in the lower right-hand corner. So we're going to assume that Kingston High School has 1,000 people in it, students in it. If 40% of the students are involved in after-school sports, then what we can do is we can say, well, which one are we talking about? Yes, they participate in after-school sports. Well, it looks like this one. So we can say 40% of those 1,000 people, yes, participate in the after-school sports. So 40%, which is 0.40 times 1,000. You can write that if you want. 0.40 times 1,000. That will give you the number of students that are involved in after-school sports. It's also known that 58% of the schools are girls. So we are only looking at the row that has females. So if 58%, we can say, oh, 58% times the 1,000 people in Kingston High School, that must be 580 students are girls. And then the athletic director said 23.2% of the students in Kingston High School are females, and they participate in after-school sports. So here's the female row. Here's the after-school sports row. If it's 23.2, we can multiply 0.232 times the 1,000 people in the high school, which will give you 232. And just like the last two-way table, this plus this equals this. All of the rows, all of the columns will add up to the total. So 232 plus what is equal to 400? 168. 400 plus what equals 1,000? 600. 232 plus what equals 580? 348. And 168, oh, we don't have a column here. 580 plus what is equal to 1,000? 580 plus 420. And then 168 plus what equals 420? 252. So just 3 pieces of information, you can fill out an entire hypothetical 1,000 table. So now what we're going to do is we're going to calculate some probabilities. The first one is we're going to call F. F stands for female. Let's say A stands for after school sports. And what we're going to do is we're going to take a look at this two-way table. We're going to figure out some probabilities. So based on what we have, the numbers we have above, we are going to talk about not F, so not female, which means male, or not A, which means they don't participate in after-school sports. So we'll say male or not sports. Well, if you remember our little probability formula for or, the probability for the or situation is the probability that they're not female, which is male. You're going to add to that the probability that they don't play sports, no sports, but then you're going to have to subtract out the probability that they are both male and do not play sports. What's the probability that somebody is male? The probability that somebody is male is 0.420, or 420 over 1,000. What's the probability that they do not play sports? Well, they do not play sports is 600 over 1,000, which is 0.600. And then you have to subtract out the probability that they are both male, which is this row, and they don't play sports, which is this column. So that would be 0.252. So take your calculator out. You are going to add up 0.420 plus 0.600 minus 0.252, and we have a probability of 0.768. What is the probability that they are female and they do not play sports? So female and no sports, which means, again, we're going to use the we don't have to use a probability formula because this is an and. So if you're going to go to one of the rows and columns, here's the female row right here, and they don't play after school sports. So we're going to intersect this row with this column. That would be this 348. So that would be 0.348, or 348 over 1,000. Over on page 413, again, we have this table filled out for us, just like what we did before. And now what we're going to do is we're going to find the probability of each one of these events. And all of these numbers are going to be divided by a total number, either in the row or the column. So what's the probability that somebody in this school is a female? We were already given that. That would be 580 over 1,000, which is 0.580. That was given to us, so that's nothing new. What is the probability that they participated in an after-school program? Well, that would be 400 divided by 1,000 people in the whole school, which is 0.400. That was also given to us. What is the probability that they're not female? Well, that would be this row right here. The probability that they're not female is the 420 over 1,000, which is 0.420. What's the probability that they do not participate in the athletic program? So we can do a little squiggly not. This is the not symbol. So not A, that would be 600 over 1,000 people in the school, which is 0.600, or 0.6. Now we have the probability of both female and participate in athletics. So here's the female, here's the participation in athletics, and this was also given to us. It is this 232, the intersection between the row and the column, which is 232 divided by 1,000, which is 0.232. And now we have the or situation. The probability of or is the probability of the female, plus the probability of an after-school sports program, and then you have to subtract out the probability of female and participating in the athletic. So make sure you know this formula for OR. OR has these three parts. The probability of female is 0.580. The probability of an athletic program or participating in is 0.400, and F and A, we just did that, 0.232. Put that into your calculator. 0.580 plus 0.400 minus 0.232, and that would give you 0.748. Here's a couple of other probabilities. What is the probability of female plus the probability of not female? Plus, we are adding these probabilities. So the probability of female is 0.580. The probability of not female is 0.420. That's all from above. And if you add those, you're going to get 1. And the probability of 1, that means 100%. The probability of not being in an athletic program, 0.400, plus the probability of not being in an athletic program, 600, that adds up to 1. Again, you've got a probability of 1, which means 100%. What do you notice? They add up to 1. Because these are complements. Because F and not F are complements. A and not A are complements. Sorry about this. A and not A are complements. So your homework, like I said before, it's on pages 416 and 417. Now, if you get stuck on anything, like if you get to a part that you really don't know how to continue, please send me a chat message, because I'm always there to help you out and get you moving along here. So have a great day. I hope everybody is staying well and feeling healthy.